Guys, I'm here to talk to you today about square roots and perfect square roots. What happens if they're positives or negatives or fractions or decimals? What happens if they're in something that looks like an expression or equation? So here we go.
So next we're going to talk about radicals and radicands. A radical is a symbol that you might have heard called a square root sign before. A radicand is this number right here that goes under the radical. So in this case, the radicand is 4. So as far as perfect squares go, we kind of already have an idea of what happens there because we've studied squares enough to know that 2 times 2 is 4, 3 times 3 is 9, and so on and so on. So we have this idea of what makes a perfect square. And so we know that it's perfect because it has exactly a whole number on each side, right? So that's not 3.1 or 3.75 or 3 and 2/16 or anything like that. That is 3.0 exactly, right? So that is what makes it a perfect square.
Perfect squares are a special kind of number, just like primes or multiples of 10. There's not every number in the world is a perfect square. 8, for example, is one that's frequently confused as a perfect square, but it's not. Can anybody figure out why?
A radical and its corresponding exponent are inverse operations. So for example, we're focusing on squares today. So this is a square root. You can tell because there's no little number up here. That means it's automatically a square root. Just like we don't write 1 in front of the x when we mean 1x. If there's no number right here, that means it's a square root. So what we're looking to do to solve this is to figure out what number times itself will equal the radicand. So in this case, 2. 2 to the power of 2 is 4. The squared and the square root are inverse operations, so they will cancel each other out. And the square root of 4 is just 2. So we just got done talking about how radicals and exponents can be inverse operations of each other if they're to the same degree. So for example, we know that taking the square root of something squared will just result in the root because everything else will cancel. So we can use what we know about that and what we know about area to figure out what the square root of perfect squares are. To get the area of this square, you're going to multiply length times width, right? So what's the length of this square? Let's see. We got 1, 2. What's the width? 1, 2. So 2 times 2 is 4. That means 2 squared is 4.
Wait, so I really just have to figure out what one side length of a square whose area is the radicand is, and that'll get me the square root.
So let's come back to these perfect squares again. We counted that the side length was 1, 2. Sure enough, 2 times 2 equals 4. We talked about before that the exponent of 2 and a standard square root are inverse operations, so they'll cancel each other out, leaving us with just the answer 2.
So I know what you're thinking. Too easy, a little too good to be true, maybe doesn't address all the issues, right? What about, for example, 0? Does 0 have a square root? As it turns out, it does. It's just 0. And it's a special square root, just like 0 is a special number, because we don't care about the sign on it. Okay, so speaking of signs, what about negatives? Can a square root ever be negative?
Okay, so I'm sure you figured out by now that there's no way to tell if that's a positive number times a positive number or a negative number times a negative number just by looking at it. We can't look at the number 4 and know for sure whether we're multiplying 2 times 2 or negative 2 times negative 2 because both of them equal positive 4. So what do we do about figuring out if this square root is a positive 2 or a negative 2?
We do the simplest thing imaginable. We don't try. The answer is going to be plus or minus. I'll show you how to notate that.
So this is how we notate for the answer is either positive or negative, and we can't quite tell which with the information that we're currently being provided.
I think this means we have a problem with the perfect squares diagram we were looking at.
That's better. Did you catch the mistake? It's very important to remember that we have no way of knowing right now whether you multiplied negative 2 times negative 2 or positive 2 times positive 2. So the square root is plus or minus 2.
Okay, fine, Miss Maba. What do we do if the radicand is negative?
What can we do then about if there's a negative under the radical? I mean, there has to be a square root for that, right? Well, kind of. Long story short, you won't see any problems like this for a while because the answer is an imaginary number. What you might see is the negative outside the radical. So the negative square root of 4. So here we would look for what is the negative something times itself that would equal negative or 4. Well, 2 squared, the squared and the square root, inverse operations, they will cancel, and all that's left is negative 2. Let's finish up these last couple of perfect squares, and then you'll be done for today. Square root of 16, side length is 4. Sure enough, 4 times 4 is 16. The exponent and the radical cancel, plus or minus 4. Last one. I'll let you walk yourself through this one.
But wait, you said you were going to do fractions and decimals and equations and expressions, right? Where's all that stuff?